afternoon, everybody. Um, Looking at our continuing study of geometry, of area specifically. So, we did a little preview on area and perimeter. What's the difference? And then we've gone through area of parallelograms, including rectangles and squares, and the area of triangles, whether they're right triangles or other shaped triangles. And we've set some expectations of writing the formula, showing all our work, all of those pieces. Today we're going to go into specifically two more polygons, but the rules now start to blend into any polygon we could have. And later we're going to get into, we'll do this more kind of on a fun level, not a specific lesson, of what I call fun polygons. What happens if the shapes are weird? So I'll preview that in this lesson, but we're not going to do a lot of detail on it. So looking through the notes that you can read, okay, the difference between shapes and polygons, really important. What's the difference between a shape and a polygon? Okay, because the rules that we're learning right now apply to polygons, not to shapes. And in that, we have specific formulas, or we can break it into things that make it easier for us. So for trapezoid, I'm going to show you both methods. I will tell you I prefer the formula all day long. It is Sunday, so twice on Sunday. I definitely prefer the video or the formula, but it's good to see where the formula comes from. Okay, so we have a formula for the area of a trapezoid. Okay, in a trapezoid, the bases are two parallel sides, and we're going to talk about that. Then we get into hexagons, octagons. Those I am not going to teach you a specific formula for. Instead, I'm going to teach you how to break them up. You don't even need to learn a new formula. So let's start with trapezoids. Okay, now up in the definition, it says it has two parallel bases. A very regular, traditional looking trapezoid is going to look like this. Okay. One of the lines could be straight. It doesn't have to have angles on both sides, but this is your most traditional looking trapezoid. Okay, so let's say that this top part is 5 feet. Now I know if I drew straight perpendicular lines down, that this part would also be 5 feet. But the problem is telling me that this entire span is 12 feet. And the problem is also telling me that this height right here is 4 feet. This dotted line that's perpendicular. Now, just like triangles, it is very important that the height is a perpendicular line between the two bases. If I had no clue what I was doing with trapezoids and I was brand new starting, I could literally cut this apart, find the area of this triangle, and this rectangle, and I would have an excellent calculation. So that would look like a triangle like this that would be 4 feet. Okay, and I know from a diagram in the book that this part right here is 3 feet. Otherwise, I might have to make some inferences or guesses. Okay, I have a rectangle that's 5 feet by 4 feet, and I have another triangle, And I know from some information in the book that this is 4 feet, and again 4 feet. So I could find 3 different shapes and I could add them together. That would totally work. But I need to write down a formula, do the math, write down a formula, do the math, write down a formula, do the math, and then add them all together. Not the end of the world. These are nice, easy numbers. But there's a formula. And the formula is a time saver. That's its purpose. So the formula is that the area equals 1/2 times base 1. I tend to make that the smaller one. And actually, let me get a color here. Okay, so I'm going to make this that. And I'm going to make that base 1. So if you can't see it well in the video, it's green on mine. And I'll pick a very different color for the next one. Versus base 2, more of a purpley color here. And base 2 would include all of these bases in my decomposed shape. Or just one number right there. So 1/2 times whatever that sum is times the height. Now notice I didn't even put times symbols in between. You could make little dots for the times dots if you wanted, but we're getting sophisticated enough that we just assume if that 1/2 is touching the parentheses, that is assumed multiplication. So area equals. Now, why a 1/2? Well, I have this shorty side and I have this longy side. I know, very good math vocabulary right there. What this is doing is adding them up and dividing. It's finding the average. It's finding what is the balance if I was able to rearrange it and make it into one parallelogram. Area equals 1/2. Base 1 is 5. Base 2 is 12. Times height is 4. Area equals, well, we do parentheses first. So that's 17 times 4. Now here's where commutative property becomes at least my best friend. You can decide what you think about it. Area equals 1/2 times 4 times 17. They're all being multiplied, so it doesn't matter what order, except that I can do 1/2 times 4 in my head. So area equals 2 times 17. Oh, and area equals 34, and it's still area, so square feet. Okay, that's a trapezoid. Again, you can decompose it and find the pieces and add them together. You would get the exact same answer. Or you can use the formula, which just averages the two bases, so we don't have to take it apart. Use commutative property where it helps you, because all you're doing is multiplying things together. As soon as you do the addition that's inside the parentheses, an order of operations would tell you to do it first anyway. Okay, now the other shape that I want to decompose and attack with you, I'm going to flip over my notebook, and you might need to do the same. And I'm going to ask for your grace and kindness right now, because I'm going to draw, and we all know what that looks like. It's not so awesome. Okay, so I'm going to draw a hexagon, and we're not going to judge Mrs. Atkinson's horrid hexagon. Okay, I'm really going to try. This is a growth area for me. Not too bad. Okay, Here's the awesome thing about a hexagon. It's just a bunch of triangles. Look. It's like a sliced up a pizza. We know how to find the area of a triangle. So if I told you that this hexagon had a height of 3.46 inches and had a base of 4 inches, and I told you that it's a regular hexagon, meaning 6 sides all equal. I know my drawing isn't equal, but we're going to believe it's a regular hexagon, 6 sides all equal. Well, then don't I just have 6 of the same triangle? So now I'm going to draw my triangle. As we're doing this geometry stuff, please draw. Some of you like to draw in your free time anyway. It will help you with the math. So we know this is 4 inches. We know this is 3.46 inches. Okay. Area of a triangle. Remember, we write down the formula every time, without exception. Area equals 1/2 times base times height. Again, look at my sophisticated writing. I'm not telling you to multiply those. It's implied now. Okay, we're the big kids now. Area equals 1/2 times 4 times 3.46. Well, this one worked out pretty well because I can do 1/2 times 4 or 1/2 of 4 in my head. Area equals 2 times 3.46. Now, 2 times 3.46 is possible in my head. I've done it with enough practice, but it is unwise to not at least double check your work. So I'm a firm believer in side work. Go over here and do the work. You will have teachers along the way who don't like that. Use a piece of scratch paper for it then. But please do it. Keep up your multiplication skills. 6 times 2 is 12. 8, that's 9. 2, 6. I have a total of 2 decimal places. Area equals 6.92. This is inches. Square inches. But I'm not done. This was only one of the triangles. If it's a hexagon, it has 6 of those. So now I need to take 6 times 6.92. Again, side work, no problem. 6 times 2 is 12. Carry 1. 6 times 9, 54, plus 1, 55. Yes, it is a great way to practice your multiplication skills. 6 times 6 is 36, plus 5, 41. 2 decimal places. So a total of 41.52 inches squared. And that makes reasonable sense. You have 6 of something that's almost size 7, and we got almost 42. That seems like a very reasonable answer. So I want you to use this information, read through your notes again, and we'll do some practice. Thanks so much.